Thank you, Jonathan. Welcome, everyone. Today, we are going to discuss about the topic, Public Void Save Money, the Developer's Guide to Unit Economics in the AI era. Today, I'm not going to bore you with the cloud budgets or with the handling the spreadsheets and stuff, and not too much on the AI, but would like to take you through most of the need of the hour items for the developers. And if I may know, how many of you are developers? Okay, good call. So, before I jump into the topic, let me introduce myself. My name is Hrushikesh Pokala, and before someone says what a typical name, you can call me Rishi. I know I hear that a lot with my name, and I'm a senior software dev at Equifax, and I can help you with your credit score, but not just with the if condition. Okay, and I have experience of around 11 years working as a software engineer, and I finished my master's in data analytics from San Jose State University, specialization on the deep learning and neural networks. And my core domain would be AI revolution right now, because it's all about AI era, right? So and when I'm not worrying about the pod bin packing or the GKs or FinOps, I usually find myself perfecting my backhand on the table tennis court, and or else driving my Tesla through almost every state in the US. So, and I would like to mention driving with Tesla up here as a main core part here, because driving with Tesla is not just going to be a simple drive. You need to understand something called as unit economics. That's a battery. That's a watt per hour per mile. So if you don't understand that unit economics, you would be finding yourself out of nowhere, running out of gas. And our system architectures are no different than that. If we don't understand the core unit economics of architecture, we would find ourselves somewhere where we don't want to be there and not utilizing them to be the absolute apt ones. And this actually reminds me, I wasn't into the understanding the FinOps for most of my career. For almost like 7 years of my experience, or 9 years of my experience, my KPIs were very simple, like speed and scalability. And if I deliver the project or the code on time, and I was a hero. But now it's not just about that. The unit economics and the KPIs are changing a lot. And for a developer, it's not just the delivery, the right code and the quality code, and now cost-efficient code. That's a change that we are seeing right now in our software development. And for an engineer, we do need these, because our first line of defense is always going to be the engineers. No matter what, any agents would be there, and many agents might be coming or being developed, but the ultimate line of defense is our engineers. And the main interesting part that I would like to mention out of my career is that at one sprint, one of my peer developers in my previous company, he has developed a good code, but and reached to the production on time. But that single commit has made up a cost that is almost twice the twice the monthly salary of both of us. So it's like that's a point where it struck me that we are not seeing the cost on the right level, and so we are not accounting that. So let me quickly jump into the agenda of this topic. It's like, I would like to walk you through the agenda of the need of the hour, the evolution, the optimization, and the multi-stack FinOps, where the code level FinOps for developers exclusively, and try to give a standard guidelines or some skills that we can try to use at the end of the day in our daily coding challenges. And as a developer, I do love Git revert, and I would have to say that most of the developers do love the Git revert, because we can always, let's say if we have messed up something and it reaches the production, that's fine. We can have a get revert and have the post-mortem analysis. But the hardest reality that I kind of learned based on my experience is that we can always revert the code, but cannot revert the bill. There's no getting back to that or like reverting that the cloud bill. In this modern world, the infrastructure deploys at a speed of commit, right? And at the same time, the costs are also going to be generated at that speed. So every single line of code that you push is a real-time decision making. And if we don't optimize the code, we aren't just shipping the features, we are shipping the financial risk. And with that, the traditional FinOps is not going anywhere. In fact, it's been more stable, and that's our first line of defense. And it's been more stable than ever. Like it's possibly the essential macro visibility that we need managing the monthly invoices and the VMs and the negotiating the reservation rates and stuff. And this is the bedrock that keeps our cloud house standing. But however, we move into a serverless era and containerized world, we are finding that bedrock isn't sufficient anymore. And we could not see the wiring inside the walls, so that particular bedrock is kind of not sufficient. And the financial teams are the masters of the monthly invoice, but in the world of millisecond execution, they cannot fix the code that they cannot see specifically, right? Why is that the process cycle more? Is it needed, or is it? It's something that the finance team cannot decide until we have a complete inspection out of it. And we are entering into a new era and the next level orientation that we are now into the AI era of FinOps as well. And we are taking the stability of traditional practices and extending them to the hands of the engineers, because that's where right now we need to focus more, because the engineers are completely involving into their contextual prompting a lot. So the urgent frontier isn't about replacing the present FinOps. It's about empowering our prompt engineers and the AI engineers to manage the context windows and generation of the tokens. And we aren't just right-sizing the instances anymore. We are optimizing the micro-transaction of every single API call. And with that, I would like to just introduce to the new epidemic that's called the AI slop, because this is the code that actually works perfect, and it passes every test and every QA requirement or every business logic that we can think of it, but it can be a financial disaster. And trust me, this is the analysis that's been all around, and we are generating the code that faster, and almost 70% of the AI code generated are seen with the severe financial inefficiencies. This isn't just theory anymore, it's practical. That's happening all around. Because we can code 20% faster than the faster now, and we are also generating the code waste at the same rate. Currently, between 20 to 40% of the total cloud compute is something that we are generating at that machine level speed. And with that unoptimized slop, it's multiplying the cloud cost as well, right? Because we are seeing some code which isn't that needed, or which can be optimized. And with that, I would like to jump into the topic code level FinOps. And here are the high level topics that I'm going to try to cover, and which can be ultimately, the skills can be used to face the most common challenges, I would say, at the front end, back end, and the prompt engineering. Because the prompt engineering is right now going to be very interesting, because we are finding new challenges up there. And to understand this, I would like to quickly take a look about the tri-stack trace. Let's trace through a single standard GCP stack, from an Angular front end, let's say, and to the Java middleware on the GKE, and the Cloud Spanner and data flow pipelines. And at every single hop, if you see, there is a hidden FinOps tax that we can reduce. And core level FinOps isn't just about looking at the dashboard once in a month, but it's about optimizing the entire architecture, because the deepest financial vulnerabilities are in the integration layers, not anywhere other else. And I'm a front-end engineer, and I usually blame backend for the high bills when I do not know about the FinOps much, on much level. And as a front-end engineer, I feel now, after knowing the FinOps is what all about, and front-end UI is or can be a true gatekeeper. A chatty front-end isn't just slow UI, it is a self-inflicted DDoS attack in your own wallet. Trust me, that is something that's going to be, which will not be unseen by the FinOps engineers, and those are the points where we have to concentrate as a front-end engineer. And let's say our Angular app constantly makes a heavy API calls and overloading the backend functions, the CPU and the GPU and whatnot, and driving up the serverless costs. In a paper API model call, intelligent internal caching is something that aren't just performance tips, it is mandatory, and it provides a bigger financial visibility. And let's talk about a simple mistake which the AI could possibly take up, and shipping our entire dev infrastructure to a production, which can be commonly happen when we use a bad model. And a simple Node.js application with a lazy 8-line Docker could easily hit a bigger size. Let's see this simple code that was generated by the AI, where we have a simple setup of the Docker, which where it has generated around 2.4 GB of Docker image of a simple Node.js APIs application. This isn't just going to be slow, it's expensive because of the transfer rate and the storage, right? By using the multi-stage builds and the weightless waterfall method, using a simple Docker ignore and the multi-stage builds, we can strip that 2.4 GB monster into a lean 24 MB. Let's say almost like 90% of it would be reduced, because most of the build time is tools are not needed in the runtime. And this is one of the biggest flaw that, as a front-end developer, that I could identify when I use a layman prompt. When I use a FinOps context prompt, this could have been avoided. And this is a real-time example based out of a simple POC that I was trying to happen. And when do I actually identify such issues, right? So in this case of Docker Matrix, I was able to identify this because the images were frequently deployed, and the CI/CD pipelines were very slow, which made me think of it, why is it taking so much of time? And the data transfers and storage costs would ultimately plumbing. So, and that's where we need to optimize at any certain point of time. And when to leave it alone, if there is something that we see it's only one time, that's fine. It's generated once, and the transfer costs and everything would be little okay. So I would like to apply every certain these logics into every certain methodologies or stages that I have at the front end at least. And this is a simple cost-aware engineering matrix or stack that I would like to take it on a high level, that an automated enforcement at the CI/CD blocking telemetry, which I'm going to discuss more later, and the code level optimization. Let's say a multi-stage builds and the distortless semantic routings and everything, where the visibility is high, you can loosen up the unexpected cloud costs and have a good financial language all along. And with that, I would like to just give a quick idea on the GKE. This is where a backend execution and database precision can help your cloud costs a little less. I took a very smaller example because that's where I could save like 70% of it, and trust me, what if I can use the same methodologies in the bigger context? And there are scenarios where the queries were like so big that could have been optimized, but there was no time or there was no visibility that it's taking time. And in the old world of on-prem servers, a memory leak just meant a crash, right? But today, with the auto scaling, the systems are so good that it will auto spin the pods, and you are spending your money into a half provisioned VMs. And look at the leak on the left. An unoptimized Java prompt process could create a significant unpredictable cost because you are paying for a half-empty VMs, right? And we need to move to let's say, optimized profiling. That would cost you less. And by profiling memory, we could actually achieve an optimal bin packing, right? And meaning it would be only paid, something like same paid for infrastructure. And we look at the query scoping at the same level. The expensive way, which involves select star, which everybody knows is very layman. But let's say in your real time, if you ask an AI to have a prompt without giving your database context and everything, it would automatically generate something like this select star. That's where the developers might be sometimes foreseeing it, or the developers might not be providing the database context to it. That's where our skills and practices, which I'm going to discuss it later, is going to be helpful. But I'm trying to concentrate on the points where right now the major small issues are happening with a bad model, and that which can be improved. And just with the select star, you could see a 75% execution time improvement. That's pretty much, that's going to stop the bleeding at the database layer, right? And with that, I would like to slowly jump into the topic of vibe and precision coding. And this is where the token wastages and every other token optimization and token economics is all about. And I'm going to try to concentrate this vibe-based coding and the FinOps way coding. That's where the most volatile layer of this AI era is all about. And on the left, if you can see that what I call is as a vibe prompting. And this uses a flagship model, GPT-4 Turbo, and injects a massive unstructured 50-page user manual. That's just a user manual. And just to find a location of a power button. This is a common RAG problem, or RAG solution, I would say, statement. And it is very friendly, but it's also chatty. And it's a financial recklessness because it uses the most expensive model just to simply find a button and without an output constraints. But look at the right side, and which is the FinOps way, which is the precision prompting. We just switch to a larger model like Claude 3 Haiku, which serves the purpose and enables the specific features like semantic caching and strict RAG chunking. These are the two topics I would like to highlight a little in the upcoming slides. But here the main point is we enforce a JSON schema. And this uses a surgical prompt kind of mechanism and returns Boolean if power button location is found, which reduces simply almost 94% of the token usage in a real time. This is simple comparison that where you can improvise the prompt which is generated by AI always. That's a FinOps way. We need to just ask the AI, is there any FinOps way? And here is the harsh reality about the mathematical reality of the LLM pricing. When we integrate these LLMs, every single API call is at high stake, real-time purchasing decision. The math is very simple, but can be brutal. Your system context plus user prompt plus RAG retrieval, all multiplied by your generation tokens equals to your financial transaction. And are you injecting a 5,000 tokens of raw PDF just to answer a 10-token question? If so, you are burning cache. And with that, here I would like to showcase front-end, back-end, and LLM API node. That's a common RAG infrastructure that we can try to have it in a simple semantic search or semantic RAGs kind of thing. This is where you would pay for the front-end UI and dictates the back-end and the workload, and pay per API model calls. Every single call to an LLM is at high stake. In this case of FinOps way of, not FinOps way of coding. And assuming the LLM tokens are infinitely available is the new way of shipping your node modules to production. That's a new node modules for us. If you don't optimize the prompt, it's going to be simply like node modules. And here is where the real time, the token burn rate multiplier, which many of would have been encountering when you work with ADKs and A2S, where here the blast radius is something that we need to concentrate. An unoptimized prompt, let's say with 2,000 tokens here, here I would take the previous point which I would have mentioned, the AI slop, which would cost fraction of a cent once. That's usually not seen at the beginning, but it feels like nothing, right? So, but place this prompt inside a programmatic loop of 10,000 database rows, let's say, and you have wasted 20 million tokens in just minutes, 20 million tokens. In the AI era, you aren't just paying paying for compute time anymore. You are just paying for every word. That's a new unit, every word inside the loop. And with that, I would like to provide 3 techniques which most of the LLMs have been developed on these areas, and understanding the LLMs using these techniques could achieve us optimize the tokens a lot. That's first thing, the semantic routing and the model tiering. Stop defaulting the flagship models like GPT-4o or Opus for trivial tasks. Okay, root simple classifications like you can Claude 3 Haiku can be used or Llama 3 can be used, which would cost almost 80% less. And one perfect example which I recently formulated is we usually have the migrations, right? We use every developer use the AI for migrations. But what if I say everybody uses a flagship model and everybody uses the same techniques? You would be ending up the repetitive process all through the time. And I have formulated one infrastructure where, or agent where I have developed in the flagship model, the Claude Sonnet 4.7 that was available during that point of time. And even with a smaller model like Haiku, using that formula, it was able to migrate almost 25 applications with the cost of like almost 30% when compared with the other ones. So that's techniques that we need to try to use in an ideal way. And about strict RAG chunking. In this case, where we use the vibe prompting, you should stop injecting the whole document. Instead, a paragraph level vector search can reduce your cost by almost 98%. Like top care relevant semantic chunks. These are the core elements of the LLMs that were developed. If you look at the ideal data analytics, these are the commonly used methods that we have been using. And as a developer, we need to understand the core elements so that we can get a simple RAG as well, a FinOps RAG. And the technique 3, which is which sounds simple, but the 80% of wastage can be saved here. Like for the model, if you enforce a strict JSON output, it overrides your natural polite tendency to a conversational filter, eliminating almost 80% in this simple case. And this is a prompt engineering efficiency funnel that I could able to formulate with my usual coding standards, like usual coding techniques and stuff. And this is the efficiency funnel which anybody can adapt from the day one. You don't need any other research about it, just all of this would be easy. And with that, we have covered most of the AI issues and stuff, and what would be the solution at the end of the day, right? Treating costs as bugs, which a developer doesn't treat it, at least right now, or at least we are trying to have those cost issues as a bug. And shifting left, the bugs. And if we don't ship the untested code, we should not be shipping the uncosted infrastructure. That's my idea about as a developer, because since when I started learning about FinOps, that's the thing that hit me hard. And moving from a 30-day post-invoice analysis to a 3-minute pre-deployment validation could actually save or potentially save with time. Maybe it's not going to be perfect for in the beginning, but it is going to help in future days. We can improvise the algorithm there, and at the end of the day, that particular quality checks can be taken place. And this is a simple CI/CD FinOps gateway that I could think of, where it can break silently, but not completely not stopping the developer to halt the CI, but just fail silently with the GitHub Actions or the Jenkins that we can think of. And with that, a simple I asked the Claude to generate a FinOps unit test, if that could be which can be in an action. And with that, it has generated me some execution time and few parameters that it could come up with, which a Java or the UI, let's say, too many API calls in the page, and it would count the number of API calls and stuff. And unfortunately, I could not able to provide the whole unit test cases, but this is something that can be generated with AI only if you ask. And this is going to be very simple with the LLM tokens, with the RAGs. It's going to be simple that you can restrict the number of tokens in your agents, in your sub-agents. You can restrict, you can split it. You can, right now in ADKs, we can have multiple sub-agents, right? You can, in each sub-agent, you can try to justify how many LLMs you have written and what is there any scope of improvement and stuff. And with that, I would like to try to give you a developer's guide where these topics that we have discussed, and at the end of the day, the total cloud spent is a vanity metric. Do not stress over 10% increase in your cloud bill if your user base grows by like 30% of it. And cost per transaction is ultimate metric for engineering efficiency. It's the only language that aligns the finance, product, and engineers into a single source of truth. And the main core essential idea that I have formulated in my career during when I started working on the FinOps era is all about using the skills, which is a package to a developer. And so far, I think I have to be very honest. These are the skills which not every team is incorporating in their systems, but slowly we are trying to incorporate in all the systems that we can, and products for the developers, like it's a package for a developer, right? The skill 1 keeps as a gatekeeper for a front end. And skill 2, it's a container optimization where we can have all the container optimization techniques, and the AI code that is generated would consider these skills to generate a FinOps skill or a FinOps component at the end of the day. We don't need to worry on the CI anymore. You can also inculcate all these skills at the IDE level. And simple, as I spoke about front end, and the container optimization at the back end, and the executioner at the SQL level. And the skill 4A is all about the most volatile layer that I was talking about, the AI, where it would generate not only just a simple prompt, but a FinOps prompt in the ADKs and the RAGs. And with that, a general engineering context and a FinOps engineering context, and the skill gap versus cost quality, these are the few topics on a high level every engineer should be able to concentrate. And it's not only just delivering the features rapidly, it's all about optimizing the cost per transaction as well in the Jira level topic that we can try to take it up. And engineers write expensive code because financial metrics are not that exposed in the component level or at the end of the day on the product level to the engineers. That's where they think I don't carry a credit card, so why do I have to worry about it? Like the FinOps team are going to pay for it. That's most of the. And this is a developer's unit economics checklist that I try to formulate, based out of what are the, let's take a FinOps most common highly or places where it can be reduced significantly. There are many topics that we can try to take it in general, but these are the high-level unit economics checklist in general, where if you ask the AI to analyze the app, trust me, that it's going to give you an interesting segments of code that we wouldn't even be thinking of at the first place. We would even question the AI that the code which is generated by AI could have been improvised. And the AS unit economics, it's about also the value and the value per output. That's the main core hot topic that you might have been listening a lot in this FinOps conference. It's all about how much you have, how much cost per request, and also the value per each output. And I would like to say that we can start where we are and try to integrate it, take step by step that the visibility first and the warnings next and the hard guardrails, which is the core essential topic which everybody has to start looking into it, because that if we do not have the guardrails, the AI is going to create a bigger blast radius because of a bad model. And trust me, the cleanup isn't going to be a simple developer's task that would be easy. It's going to be a very tedious task because not many of the developers are seeing the code that is generated by AI completely. So we need to concentrate on that and have those guardrails and skills at the core layer. And as always, a centralized code-driven platform ensures all teams track usage, telemetry, and billing through the exact same financial language. That's where we can grow as a team. And what's next? As a developer, I would like to integrate, and I've been integrating these real-time cost feedbacks into my CI/CD pipeline. So that's where I can try to have the best visibility. And as a researcher, I try to investigate the defined shared financial metrics for future models. And as always, FinOps as code isn't about slowing down. It's about engineering maximum business value. Any questions?
If you haven't seen this before, Catchbox, Crashbox, it is soft, doesn't hurt if it hits you, and I can't aim very well. It's going to the gentleman in the back, so it's going to go over all of your heads, and then we will see where it goes next. When you talk into it, please right up against your mouth. It'll pick you up just fine. Ready? Here we go. Don't break the camera. Almost perfect.
So let's say you're just getting started in this journey. Can you use input credits just to ask whether or not to give you multiple models and which one's cheaper? That way, before you even get to code generation, you start doing output models that are more expensive.
Yeah.
You have like a gate just to start.
Yeah, I mean, I would be honest with you. Again, using a model to judge the other models would again introduce a new cost during the runtime, which is absolutely perfect, and which most of the teams in my team, I mean, most of the developers in my team does it in a way. And I have developed a simple tool for it. In fact, that's where I use a smaller model to make my prompt a better way, in a way, so that I can get my output in the first go, rather than, again, iterating with the model comparison. Every model gives us the best output only if we ask the right question, right? So that's where I try to concentrate on the part where let's begin the refining the prompt first rather than asking multiple models. I mean, if I
Yeah,
if
that
I
makes sense.
answered
Thank you.
Thank you.
Thanks for the presentation. Can you talk about how you are injecting the cost data into the CI/CD?
Yeah. So frankly speaking, this CI/CD is something that we are still building on a whole scale level. But the idea up here is that right now we have a POC level of point here. That's where we have a certain test cases which I could able to come up with a test command in my Angular app, let's say. We are starting with the front end up here. So that's where the front end has a new test command, or I would say here the cost command, where we have certain test cases that it would run and analyze the code on each component, or let's say on a scale of E2E testing kind of thing, and come up with some metrics that we can think about, let's say how many transactions in that API calls that could have happened on the load and on demand of how many buttons we have, and targeting those number of buttons. If we click it, is there any API transactions? And overall summarizing on a simple use case, how many transactions we could come up with. So it's just not going to stop the whole CI. It's going to break silently, that's it. That's the whole CI/CD formula that we are trying to incorporate.
Hey everyone, producer Andrew here. Thanks for watching. Check out the rest of our channel for more FinOps content. Like, subscribe, and leave questions and comments for our speakers. We appreciate your support.